Welcome everyone to the webcast. I believe you should be able to hear me right about now. I'm going to wait a few seconds for people to come in. All right, so I think we can go ahead and start. Everyone should be able to see the slide deck at this point. Want to do a quick introduction. My name is Zach Golitzer. I am one of the blockchain developers at Chainworks. Just a brief background on Chainworks before we get started, because I know everyone's here to learn about Hyperledger. But Chainworks is one of the world's first independent blockchain advisory, development, and B2B platforms firm and products. They are the blockchain technology with a deep focus on innovation, whether that's through internal innovation labs or co-innovating with its enterprise customers. Chainworks empowers blockchain for the enterprise through its Imagine, Create, Operate service delivery model. The starting point of blockchain integration journeys is always going to be the ideation workshops held in collaboration with the business stakeholders. So we'll have a little bit more on that at the end of the presentation. I'll give some ways that you can get in contact with us. But without further ado, I think I'm going to go ahead and start talking about what everyone's here for. So I'm sure most of the attendees have heard of Hyperledger, and because it's a very widespread, well-known global open source software project. But I'll give a quick overview of what this is, and then we'll dive into two of the projects that Chainworks has been working with very deeply. So Hyperledger was first launched in 2016. It had 30 initial founding corporate members, and the governing board of Hyperledger, which is headed by Brian Behlendorf, is 21 members, and it's partnered with the Linux Foundation, which has several projects, or I guess organizations, under their umbrella. Hyperledger, as an organization, now has 10 active open source software projects, all centered around blockchain technologies. What we're going to be talking about, though, is the Hyperledger Fabric and Hyperledger Composer projects. So we'll start with Fabric. It was first launched in 2015, actually prior to the Hyperledger organization. This was kind of a project with several stakeholders that were kind of hacking around on it, and it became more of an official project once Hyperledger picked it up. Hyperledger Fabric is a private and permission consortium blockchain, basically just meaning that instead of your public blockchains like Bitcoin and Ethereum, where it's pretty open and available to the public, this framework allows you to create blockchains that are kind of siloed within your organization or within a business network. It has several capabilities. One of them being, and I guess I should preface this with, all of these capabilities are very modular and pluggable. That's the last point there. But that's a very important point to make, because many of the blockchain frameworks are not exactly compatible with an existing IT infrastructure. Well, Hyperledger Fabric really is. There's a lot of different places where you can plug in parts of your existing systems and not have to reinvent the wheel within your organization. And one of those is the identity management. You can use a certificate authority of your choice, whether that be global sign, DigiCert, etc. So there's no opinionated idea of what you have to use for your identity management. There is privacy and confidentiality through what we call channels. We'll dig into this a little bit later, but essentially within our business network, we can take two or more of the participants and put them in channels and have them sending blockchain transactions to each other without the rest of the network knowing what's exactly going on. And then finally, one of the biggest appeals to this type of framework is the segregation of the consensus and the chain code execution, which I know is a mouthful there, but essentially what that is saying is, as opposed to something like Ethereum, which is Ethereum has the EVM, or the Ethereum virtual machine, which is a smart contract engine. The way that consensus is reached on the Ethereum network is each node in the entire network actually has to run every piece of smart contract code on their local machines to provide that consensus. And with the Hyperledger Fabric model, we're actually segregating that so that the consensus is happening in one area while the chain code execution is happening in another area all at the same time. So it's a very efficient model, and it allows for a high transaction throughput. So just like the Bitcoin or the Ethereum networks, there are node types, and I'll be going over those really quickly, and then we'll dig into how they interact. So the first node type would be the membership service provider, or in other terms would be the certificate authority that I just talked about. The Hyperledger Fabric architecture uses X509 certificates through a public key infrastructure, and each member or each organization within a business network will run their own certificate authority. The next node is an ordering service node, which is not necessarily run by every organization within your Hyperledger network, but at least one of the organizations has to run this, because this particular node is entirely responsible for ordering transactions in blocks and propagating those out to the peers in the network. So instead of something like Bitcoin, where all the peers engage in a proof of work algorithm, where they are actually all independently trying to come to consensus on the state of the blockchain, the ordering service node will interact with the peers who are validating the transactions, and then will order the blocks and send it back out to the peers. The next node type would be a client. So this is something that you would see for an end user. So if you have an organization running a Hyperledger network, this would be the screen or the application that the employee of that said firm is going to see. And this is how, the end user, the employees of the network, are going to interact with it. And the backbone of every Hyperledger Fabric network are obviously the peers. So there are two types of peers. There's just the regular peer and then an endorsing peer. You'll see the difference between these in a few later slides, so I'm not going to go into too much detail. But essentially, the endorsing peers are ones that will actually run the chain code on their machines to validate it. And one thing that I will add here, because I know a lot of people get confused about this, when I'm mentioning this thing called chain code, this is essentially the same thing as what an Ethereum developer would call a smart contract, or as more commonly known in the blockchain space. So there's really no difference. This was just a term that the Hyperledger Fabric core developers decided to use. They called it chain code. So this slide is a quick representation, or a very basic representation, of what a consortium network might look like in a Hyperledger Fabric network. And when I say consortium, I basically just mean a group of organizations that are all acting on one global distributed ledger. And you can see that organizations 1, 2, and 3 don't all have the same exact structure. You can see that organization 1 has the ordering service node, also has this little thing in there. You probably can't see it too well, but the little white rectangle is the Genesis block. And the Genesis block has information, basically one big configuration block of certificates of all the organizations and peers in the network, and information on how to bootstrap the network. So this is really important, and this Genesis block is downloaded primarily on the ordering service node. And you can see that the organization 2 and 3 are not running in OSN, which is totally okay. And finally, if you'll notice, with each of the peers in the network, I had not mentioned this before, but you have the ability to run an external state database. So at the moment, CouchDB is the only externally supported state database. And then finally, each of the peers, if they are considered endorsing peers, well, actually not just endorsing peers, every peer in the entire Hyperledger network is going to have a chain code container. So this is where all the chain code has been installed on that peer. So this is just a brief review of what we just looked at. Each organization in the network can run 0 or more, or usually just one ordering service node. They can run as many peers as they want. They have to have at least one. There's a certificate authority running for each of the organizations in the network. And then optionally, you can have what I just talked about, the external state database via CouchDB. If you do not choose to use this, it's just internally, it's using LevelDB in the peer container. And then finally, if you've built your network on Hyperledger Composer, you can run a REST server container, which allows organizations to interact with your blockchain network through the REST protocol. So for anyone who has delved into, legacy or modern architectures, this is a very common way to interact with applications. So that's a real plus for the Composer framework. And then finally, each organization is going to be running all of this in Docker containers. So this is a little bit confusing if you don't have any familiarity with Docker, but essentially Docker containers are little processes that are running on your computer. A lot of people liken them to mini virtual machines, but I don't think that's a fully accurate way to express them. They're really just processes, or processes with their own isolated environments. And if we go back to the previous slide, you'll see that I've outlined this. Each of the organizations are running in their own Docker virtual network. And these virtual networks are going to interface between each other, and that's how the different organizations will interact. So I wanted to go through the basics of how the Hyperledger fabric is set up within a consortium, and then I'll take you through basically how the transactions are executed within those networks. So you can see here on the screen there is a little diagram with 3 organizations. You have organization 1, 2, and 3, each of them running their own peers. And we'll consider organization 1 to be the quote-unquote consortium leader. So this is the organization that's going to be doing a lot of the administrative setup for the Hyperledger Fabric network. And the first step in doing so is to actually install and bring up the Hyperledger Fabric network in the form of Docker containers. So each organization is going to be doing this kind of on their own. And once that is done, organization 1, the consortium leader, is going to create a global channel. So this channel is going to include everyone that's in the network, and then in the next step, they'll be able to actually join this channel. I apologize if there's any sort of lag with the slides here. Hopefully no one's having too much of a problem. If so, we can you can always reach out and I'll give you that contact information in the end. So on the next slide, you can see that once organization 1 has created that first global channel, then all of the peers within that within the consortium network and within each organization 1, 2, and 3 are going to find that channel and join it. So they're going to do so using their X509 certificates or RSA certificates, and they will validate with their own certificate authorities. But each of the certificate authorities actually has the same configuration. So each organization is going to have the same crypto config, essentially. So they'll know how to validate each of the peers. The next step is you would ideally have some sort of chain code developed. This is a whole different process, and you can choose to do this natively with Golang for Hyperledger Fabric, or you can use the Composer framework, which I'll be talking about in a later slide, to develop your chain code in just plain old JavaScript, or I believe they're trying to support multiple languages in the future. So step 3 is we need to install all the chain code on every single peer in the network. And so how this would look in real life is each of the administrators at each organization is going to get their hands on, the global chain code that the entire consortium has agreed upon. They're going to take that chain code and then they're going to literally get into the bash session of a Docker container and quite literally install those files on each peer. So it's a manual process. It can be a little bit easier with Composer, as we'll see in a minute, but this is a manual process and it's not going to actually change anything about the network itself. So once the chain code has been installed on each of the peers, now we have to go through a slight configuration where we send this thing called an invocation transaction. So this only needs to happen through one organization, and it's what we call instantiating the chain code on the network. So once this first invocation transaction has been sent by one of the organization's peers, then the chain code has been quote-unquote instantiated across the entire network, and the network can start using that global channel. So I'm going to actually take this as an opportunity to go through the flow of a single transaction. And although the invocation transaction is a little bit unique, I think it's okay to kind of use it as that example. So we'll imagine it in very practical terms. We'll say that we've got an employee from organization 1 that we'll call the consortium administrator. So as I mentioned in previous slides, organization 1 is the quote-unquote consortium leader. And so the administrator at that organization is going to be the one instantiating the chain code across the entire consortium network. So they're going to send a single invocation transaction using the Fabric software development kit, or you can actually do this within a Docker container, but that's a little bit more difficult. So they send this invocation transaction, and then as you see, the Fabric software development kit, or essentially the client, will send this particular transaction proposal out to all the endorsing peers in the network. So as we saw in the first diagram, we had the three organizations. Org 1 had one peer, and then Org 2 and 3 both had two peers. But for the purpose of this example, we're just going to assume that each organization only has one endorsing peer. And so organization 2 and 3, they have one endorsing peer and one non-endorsing peer. So for this invocation transaction, this is going to be sent only to the endorsing peers in the network. Once those peers receive the transaction proposal, they're going to go through a 4-step process to make sure that this transaction is correct. So the first thing they're checking, and this is all happening behind the scenes, is happening in the form of computer code. So the first thing they're checking is that the transaction proposal is well formed. So is the syntax correct? Is this transaction proposal object what we expect to see in the Hyperledger Fabric network? Number 2, it's going to check to make sure that this transaction has not been submitted in the past. So this is like the replay protection. If anyone has been kind of involved with Bitcoin, that's a huge problem that it essentially solves, is the double spend problem. So obviously we need to protect against that within Hyperledger Fabric as well. Number 3, we're going to make sure that the identity that is submitted, the invocation transaction, has the correct X509 signature. So each organization is going to use their own certificate authority node to validate the transaction signature. Finally, we're going to look to make sure that the identity who submitted this particular transaction has the authority and permission to do so. So as you know, I mentioned that this network can be a permissioned network, meaning there are certain types of chain code that certain identities in the network have been configured to be able to do, and some are not allowed to do. So once those 4 checkpoints have been passed, we can consider this transaction proposal to be valid. And at that point, we're going to send the transaction proposal signatures from each of these endorsing peers back to the original identity that submitted it. So this original client gets all of the signatures from their endorsing peers, and what they're going to do now is send it out to the ordering service node in a big blob. So this is just think of it as a package of transaction approvals that the ordering service node is going to receive. And the SDK, the software development kit, will analyze the responses from the peers, making sure it matches the endorsement policy of the network. So in other words, if the endorsement policy says that every peer from every organization must approve, then it makes sure then that criteria has been met. And then it bundles it up and sends it to the ordering service node through the global channel that was created in the beginning. And at this point, no state has been changed in the network. This is prior to that state change, when all of the peers will execute the actual transaction on in their chain code containers. So the final step is the ordering service node does some final checks and then delivers the transaction packed in a block to all the peers in the network, including the non-endorsing peers, who will do one final check to make sure that the block transactions meet the endorsement policy. And then finally, they will update their local state, or essentially execute those transactions, or single transaction if that's the case. So that's the basic flow of a Hyperledger Fabric transaction. And hopefully throughout this presentation, you've gotten a little bit better idea of how the Hyperledger Fabric framework is set up. So before we get into the demo in Q&A, I think we're kind of pushing up against the time, so I'll probably skip out on the demo a little bit, but I wanted to, well, let's not do that yet. I wanted to just go through a quick overview of what Hyperledger Composer is, and then give you an idea of how you can get in contact with Chainworks. So Composer, I've been talking about this throughout the entire presentation. What this is essentially a development framework or a layer of abstraction on top of Hyperledger Fabric. So developing business networks within Hyperledger Fabric and writing native chain code is a very complex process, and it's not necessarily suited for every organization. It requires a bunch of training, obviously. You're going to have to hire resources that will have to learn this entirely new framework, but there is a solution, and that is Composer, because this allows you to develop applications as you normally would, but then deploy them through the Composer abstraction onto the Hyperledger Fabric instance or the consortium network. So some of the features include writing chain code or quote-unquote smart contracts in plain old JavaScript, deploying and managing consortium networks from a simple Composer client, so that just from the command line, you can actually manage entire Fabric networks. You can migrate networks seamlessly. This is a huge pain point within any blockchain protocol, is the migrations, because unlike a regular application where you can just migrate easily and not worry about the state of the ledger, with a blockchain network, you have to worry about, what is the previous state of the ledger and how will this migration affect it, because we're essentially saying we're going to change the chain code that's running. And then finally, you have this thing called the Composer Playground, which you can experiment around with and build applications. And so in a second, I will give you, well, I'll go ahead and just show that right now, because we're going to run out of time. But if you go to the composerplayground.bluemix.net, you can see that there's a nice graphical interface where you can interact with business networks. And if I go ahead to deploy a new business network, we can click empty business network, and hopefully this will work. It's been a bit buggy recently. Okay, so we connect now, and now you can see there's a whole development environment just in the browser that you can experiment around and write different business networks. And then finally, you can click this little export button, and you can see that I've downloaded this thing called a BNA file, which is your entire network packaged up in a bunch of binary chain code. And that BNA file can then be deployed to a Hyperledger Fabric network. So it's very flexible, and if we had more time, I'd go into it, but at this point, I think we're pushing up against the end. So I wanted to just let you know how you can get in contact with us. We offer a free 15-minute consultation if you go to chainworks.com/contact, or you can drop us a line at ping@chainworks.com, and we'll get in touch with you. So if you've had any questions throughout this webinar that have not been answered, feel free to send it to that line. And you can also contact me, Zach, Z-A-C-H, at chainworks.com. So at this point, I unfortunately think we've kind of run up against the end of the allotted time. So there won't be any Q&A, but once again, we will go ahead and offer that out to you if you want to contact us. So thanks again for attending today, and I hope you learned a lot about the Hyperledger framework and that we can keep this discussion open in the future.